can you be precise when you solve math problems? Think about this question during the lesson. A farmer is building the small horse riding arena. The fencing around the arena is built using 3 rows of wood planks. The farmer decided to use wood planks that are 8½ feet long, so he ordered 130 of these wood planks from a local lumber yard. Did he order enough wood planks to build the arena? Explain.
Let's find out.
How do you find the perimeter of a rectangle? To find the perimeter of a rectangle, find the sum of twice the length and twice the width. Think, what do I need to do to solve the problem? I need to be precise. I will find the perimeter of the arena and find the number of wood planks needed to build the fencing. What units are used in this problem? What will the answer to this problem look like? The units are feet and number of wood planks. The answer to this problem will tell whether or not the farmer ordered enough wood planks and will include an explanation why. Here's my thinking. I have to find the perimeter of the area. What is the perimeter?
Select your answer.
The perimeter is 373½ feet. The farmer needs enough wood planks for 3 times the perimeter, or 1,120½ feet. Now divide to find how many 8½ foot long planks are needed. (1,120½ divided by 8½ equals 131 14/17. The farmer needs at least 132 wood planks to build the fencing. He only ordered 130, so he did not order enough wood planks.
The farmer decided that he ordered enough planks for an arena that measured 115¼ feet divided by 63½ feet. Is he correct? Explain.
Before we can decide if he's correct, we must find the perimeter of this other arena. So we're going to follow the example of finding the perimeter. And we're going to do 2 times 115¼ and we are multiplying by 2 because the arena is shaped like a rectangle, so that means there's 2 parallel sides. So there's 2 sides that are measured at 115¼ times plus 2 times 63½. So we need to multiply these two numbers, but first, well, we can multiply. Let's change the mixed numbers into improper fractions. So 115 times 4 460 plus 1 is 461 over 4 times 2 over 1. 63 times 2. 126 plus 1 is 127 over 2. And multiply by 2 over 1. Okay, and then you multiply straight across. Actually, I'm going to show you what I showed you before. I'm going to simplify first by looking diagonally across. 2 and 4 have a common factor of 2, so 2 divided by 2 is 1. 4 divided by 2 is 2. So I am left with 461 over 2 plus, if I look diagonally here, 2 and 2 have a common factor of 2. 2 divided by 2 is 1. 2 divided by 2 is 1. So now I have 127 over 1. And so now I need to add these together. And let's make sure they both have the same denominator before adding. So we have 461 over 2 plus, and we're going to multiply this by 2. So we have 2 as the denominator and 127 times 2 is 254, because to add fractions, the denominators must be the same. So now we can add these going across. 2 is going to stay the denominator. 254 plus 461 is 715. And that's an improper fraction that we need to change into a mixed number. Let's see, 2 goes into 715. Okay, so we have 3 times, that equals 6. 1. Bring down that one. 2 goes into 11. 5 times, that's 10. Bring down the 5. And then 2 goes into 15 3 times. Oh, not 3, what am I thinking? 7 times, that's 14. And I'm running out of space, so 15 minus 14 is a 1. And so my final answer would be 357 and 1/2. That is the final measurement of the perimeter of this new arena. So this is a 2-step process. So we just found the perimeter of this arena. Now we take this information and we need to find out now if he will have enough wood planks. So I'm going to erase all of this work and do the second part. Now I'm taking the 357 and 1/2 and I'm going to divide it by the 8.5 planks. I'm sorry, the 8.5 length planks, because we need to find out how many of them we need to use, or if he has enough to use. So we're going to divide. Before we divide, we're going to change our 357 and 1/2 into into an improper fraction from a mixed number. So 357 times 2 plus 1 is 715 over 2 divided by, and 8 times 2 is 16 plus 1 is 17. And now we can divide by multiplying the reciprocal. So we're going to find the reciprocal. So we're going to do keep, change, reciprocal. 715 over 2, change division to multiplication. 17 over 2 will give us 2 over 17. And then now we can multiply straight across. Again, I like to see if I can simplify things. So I'm going to look across and see if I can simplify. 2 and 2 have a common factor of 2. So if I divide both by 2, I can get a 1. 715 and 17 I do not believe have a common factor, so we're just going to multiply straight across. So 715 times 1 is 715 over 17. Now, if you look back at the original example, it says that the fence is made up of 3 rows of wood planks. So the 715 over 17 represents 1 row of the fencing all the way around the arena, but we need to have 3. So I'm going to take the 715 over 17 and multiply it by 3 because I need to know the total for the 3. So 715 times 3 is 2,145. 17 times 1 is 17. Now I'm going to take this number and take it from the improper fraction into a mixed number. And to do that, I need more space. So I am going to erase this work here. Now I'm going to divide 17 and 2,145. 17 goes into 2,145. Once into 21. 21 minus 17 is 4. Bring down the other 4. 44 divided by 17 is 2. And so 17 times 2 is 34. Subtract that is 10. Bring down the 5. 105 divided by 17, 6. 17 times 6 is 102. That's 3. So we have 126 and 3 over 17. That will be our final amount of fencing. And he ordered, if you go back to the example, original example, 130 of these planks. We have less than 130, which means yes, he does have enough planks.
A 26 and 2/10 mile marathon is being planned. Part A. Water stations are being set every 2 and 6200 miles along the marathon route and at the start line. How many water stations are needed? The map shows that the marathon route has many twists and turns, and it passes through much of the city. However, for this problem, you can think of the route as a straight line, much like a number line. Label the starting line as 0 miles and label the finish line as 26 and 2/10 miles. Next, divide the length of the route, which is 26 and 2/10 miles, by the distance between water stations, which is 2 and 6200. The quotient is 10. Now we need to check whether 10 is the answer to the problem. Use the number line to represent the division problem. The equation shows that the route can be divided into 10 sections, each 2 and 6200 miles. However, there's also a water station at the start line. Add 1 to count the water station at the start line. Let's look again at the map of the marathon route. The stations will be placed at the start line and then at every 2 and 6200 miles along the route. A total of 11 water stations are needed for the marathon. Part B. There are 5 medic tents equally spaced along the marathon route, including one at the starting line and one at the finish line. Where should the other 3 medic tents be placed? Again, think of the marathon route as a straight line. Label the starting line and finish line. You already know the positions of 2 of the medic tents. One tent is at the starting line, and another is at the finish line. The other 3 tents are evenly spaced along the route. How can you find the distances along the number line for the 3 tents? Notice that the 5 medic tents divide the number line into 4 equal sections. So, divide 26 2/10 miles by 4. That's the location of the first medic tent after the one at the starting line. 6 55/100 miles. To find the location of the third tent, double the distance. The third tent is located at a distance of 13 1/10 miles. To find the location of the fourth tent, triple the distance. The fourth tent is located at a distance of 19 65/100 miles from the start. The fifth tent is at the finish line. In addition to the tents at the starting line and finish line, the other 3 tents are at distances of 6 55/100 miles, 13 1/10 miles, and 19 65/100 miles.
The number of runners who finish the marathon is 320. Runners donate $2.50 each mile they run. How much money is donated? Explain.
Now we have to decide how much money. So, 320 people finished the marathon. From the example, it told us that the route was 26 2/10 miles. So each one of those 320 people ran or walked that distance. So we're going to multiply these two numbers together and we get 8,384. And so that's how many miles total were walked or ran by these people. Now we must decide how much money. So the money donated was $2.50 for each mile. So we're going to multiply the miles, which is 8,384 times that $2.50. And that total is $20,900. So $20,960 total. So that is the amount of money that was donated from everyone who ran in this marathon.